So in the continuation of this data analysis with the help of supervised machine learning, so already we have implemented our regression models with the help of simple linear regression model and your KNN based regression model. So now what I am trying to do now, I will implement the classification type of models or algorithms to predict the success. So in this data, you already know there are two attributes were used. One is that is you are trying to predict the box office collection, which is a continuous data. On the other hand, in classification type of problems, we are trying to predict the success of the movie. So the process or that code is more or less similar for classification type of problem implementation, except the model names till definition of your till definition, or you can say the testing and training of the data, that part is defining the testing data and training data is same, but the different is in the case of classification that we have to define a new target variable or your dependent variable, that is nothing but the class, and another is that you have to implement different models or different algorithms. So in the same drive, in the same code or script, I'm just trying to implement the classification models, solving classification problem with the help of logistic regression and KNN based classifier. So right now I'm just changing the name of this script to Bollywood Success, or yes, as in this entire script, not only we have tried to predict the box office collection, and the next we are going to just try to predict or estimate that whether a particular movie before release, whether it is a success or failure. So now here we will add a different section. So I'm just trying to add a text after the end, at the end of this row. So I'm just writing classification model implementation, and the same thing you can observe here, that section is created, and now here I'm just adding the code. Now the thing is that you have to call that particular library where the classification type of models are used. Just remember here, just when we define or we call all the libraries which are required for this particular that implementation. So here what we ask that sklearn.linear underscore model, from here we called or imported our linear regression. So similarly we can import our logistic regression also. So I'm just creating in this last cell only, I'm just writing call the libraries for implementation of logistic regression and KNN based classifier. So hence, so you have to just call from, so again you just check, it is already suggesting from sklearn dot model import logistic regression, and with that again from sklearn dot neighbors import K neighbor classifier. And also we have to define the performance matrix for the model. So remember, in case of logistic regression, in case of simple linear regression, what we call from sklearn dot matrix import mean square error and r square score. So in this case we have to call, or we have to define, or the matrices as confusion matrix and accuracy and precision, r square, all these things. So first of all I will just call for confusion matrix, then accuracy, then precision score, and definitely recall score, and last F1 score. So once you have, just check if any spelling mistake or any other things are so again recall score. So here actually I did mistake. Okay, now it is perfect. So let me just rerun all first. So what will happen, it will make sure that your data is mounted into that particular data frame. And so next again I'm just adding another code. So here what we will do, we have to just define the because already our data is mounted to D1, the data frame or DEF. So we have to just define our train and basically the features, input feature and output feature. So in that case already we have created our feature set, which are basically used to predict the success. So straightforward, I no need to define this input var. So because already you have defined input var equal to budget, views, likes and dislike, so that is nothing but your xf. So what I am doing, I'm just only define this y. So for understanding purpose, I'm just copying entire thing. And again separately I'm just telling hashtag defined the feature list for model implementation. So here I'm just copy paste this. In place of YBOC, here we can use the success, SUCC, that is nothing but the binary variable. 1 means success, 0 means failure of the particular movie. So now if you just hit the run button, so it will show that okay, this tick means it's correct. Now next is again already we have splitted the data into training and testing, that is 30%. And now what we have to do, we have to just train the model, nothing else. So in that case what I will do, okay, another thing, I have to just define the training testing data once again as my x and y actually changed this time. So what I'm doing here, I'm just changing this variable names to I and O. So I is input, O is output. So this is different for the classification model. So in that case, I have to again redefine my training testing data set. So just copy paste this entire code over here, this entire thing, and then in place of X, I'm just mentioning is I means your input features, and O means your output features. Here I have to just change I and O. So there is a distinct that O means, and I and O is for classification, and X and Y for regression. Okay, so here I can put some note. Define the training and testing data for data set for the implementation of classification model, and then I can just define my two models. Okay, I is not defined, so here only I have to just anywhere I have used. Okay, here again I'm just rerun this. It's okay, done. Then again you just add a code where you have to just train the model, the hashtag train the logistic regression. So I can write, so new name Bollywood success underscore binary regression BR. I'm just writing it BR. So this is binary regression. Then you have to name the function for logistic regression, and then you have to just train the model BS underscore BR. Again BS underscore BR dot fit. Within bracket you have to just mention your training data set, that is I underscore train and comma O underscore train. So once you hit, so it is running. So what is okay, so the model is actually now trained for you. Now it is ready to predict. Now side by side, what I wants to create another model, that is for KNN. So here also let us just build the KNN model also. So BS underscore KNN KNC. I'm just writing KNC because KNN K nearest neighbor classifier. So K nearest classifier within bracket. Okay, here I just wants to define N underscore neighbor equal to let's say 3. Then again BS underscore KNC dot fit, similar to your logistic regression. Within bracket you have to just mention the training testing data set, training data set. Now this is for train your the KNN classifier. So if I hit again run button, so my model is now trained. So the time is to now check what is happening within the model or the model prediction. So similar to the your linear regression, you can also create a prediction. So in that case, what I will use the same kind of structure of code for prediction. So two prediction will be there. One is with the KNN and another is with the. So in case of just write ypred underscore, this is for logistic regression. So binary BR, I will just use BR, and this in place of BS, I'm just writing BR and predict. So in place of X test, you have to just write I test. And similarly for KNN, predict underscore KNC, I have to just mention BS underscore KNC dot predict within bracket same I underscore test. So here I'm just putting a note predicting the class with the help of KNN logistic regression and KNN. So here we have created the prediction. Again, when you have created the prediction, now we can easily compare the two models. So for that, what I will be doing here, first of all, I can just check, calculate the confusion matrix that already told, and then accuracy with the help of these things. So in that case, what I will do, I will again generate a code. So basically here, calculate or evaluate the performance, evaluate the performance of the classifier using confusion matrix and accuracy, recall, precision, and F1 score. So for that, so what I should write, so here we will just write print or just write, or here, or let's say, okay, another thing, so we just forgot to just print the coefficient of the logistic regression, because it is required to just explain the model's capability or the model explanation of the model. So here only I'm just creating hashtag calculate the coefficients of the logistic regression, as there are logistic regression coefficients are calculated, so it is easy to find out. So same here also, I will just calculate the coefficient with the help of same. So here also you can just use the same code as linear regression. So in place of BSLR, I have to just write BS particular classification model name BR, and similarly here also BR. So again, if I hit here, so it will give you the particular coefficient for different features, because I just remember the log likelihood of any particular event, basically the log odd equal to intercept plus beta 1 into x1, beta 2 into x2, beta 3 into x3, beta 4 into x4, as we have 4 variables. Now here in case of KNN, specifically no different coefficients are generated, or it is dependent, highly dependent on the neighbors. So in case of a classifier, you just consider the highest vote for a particular class among the neighbors, and based on that only you just select the predicted value or the predicted class. Now here just remember, in case of classification model, we always select this in neighbor as an odd number, as in case of even number, maybe 2 ones and 2 zeros are there, then you are in kind of a indecisive that what should be the class of that particular unknown instance. So to avoid those kind of situations, always consider the number of neighbor as odd number. Don't consider them as an even number. In case of regression, maybe that even number works, but in case of classification, it could generate some kind of an error, and that may be kind of a cause of wrong prediction or lower performance of your model. So always try to select an odd number in case of neighbors KNN algorithm. So now next one, we are trying to find out the performance of the model. So first we will go for performance of logistic regression, then we will go for performance of KNN. So here I'm just writing measure the performance for logistic regression. So here I'm just writing confusion matrix So here again you can just check that the definition of confusion matrix is nothing but you have to just put the data, so which will help you. So again this highly dependent on the internet. Let's say right now I don't have that access of internet, so slower speed of internet. That's why it is creating some kind of error. If you are in that case, your offline coding skills are very much required. So again, when I am writing this confusion matrix, so within this I can just write the data that your predicted or your predicted class and your original observed class for your testing data. So basically I have to use O test, output test, and your predicted value. So that is, what was the predicted value for my logistic regression model? It was y underscore predict underscore br. So I have to just mention that also, y underscore p rad underscore br underscore and comma, another we have O test. Okay, so again I think this is creating confusion. So again I'm making O, because we are using O for